Hello my dear students, in the previous class we have discussed about problems on replacement theory. Now we'll have a look on examples on transportation problem. So let us start. Find a basic feasible solution to the following transportation problem using northwest corner rule. Also find the transportation cost associated with the solution. Destination. Three destinations are given D1, D2 and D3 and origins. Three origins O1, O2, O3 and here AI stands for availability of goods and BJ stands for requirement of those goods. Fine. Then when you take the total of availability and requirement, you should get the same answer. That is 9 plus 14 plus 13 is 36 and 10 plus 15 plus 11 is 36. So summation AI equals to summation BJ. Hence the given transportation problem is balanced. So let me start the solution. Here total availability equals to total requirement. That is summation AI equals to summation BJ equals to 36. Now, so the method is northwest corner rule. So we have to start solving the given example from the northwest cell. That is first row and first column. Fine. Start from the northwest corner cell 1, 1. 1, 1 stands for first row and first column. Right? Then x11 stands for number of units for the first row and first column. First row and first column equals to minimum of AI, BJ. First row, availability of the first row and requirement of the first column. Here we have to write minimum of 9, 10. So minimum of 9, 10. What is minimum among 9 and 10? That is 9, right? So allocate 9 for the first cell. First cell is first row and first column. Here we have to allocate 9, right? Then here first row is satisfied because the total availability for the first row is 9 and we have allocated 9 here. So first row is satisfied, not necessary to move for the second column and third column because 9 equals to 9 here. But here there is a balance. Total requirement is 10 and here we have allocated 9. So what is the balance? 1. The remaining balance is 1. So we should move for the second row and first column. Second row and first column. Right? Now, here first destination is satisfied. Move vertically to cell 2, 1 and make the second allocation. So this is x21, second row and first column. x21 equals to minimum of. So row, second row, availability of the second row is 14 and the requirement of the first column is 1. It is not 10, it is 1 because already here we have allocated 9. Out of 10, we have allocated 9 here. The remaining balance is 1, right? So here you have to write 1. So 14, 1. Minimum of 14, 1 is 1. So for x21, the answer is 1. Here allocate 1 for this. Okay. Now 9 plus 1 is 10. So first column is satisfied and first row is also satisfied. Right. Then you have to move for the second column now because here 9 plus 1 is 10. But the second row, total of the second row is 14. Out of 14, we have allocated only 1. We have allocated only 1. The remaining balance is 13 here, right? So, go for the second row and second column. So, x22 equals to minimum of, here, what was the balance? 13. Because already here we have allocated 1 and out of 14, 1 is allocated. So, remaining balance is 13 here. So, 13, here 15, column total 15. So, 13, 15, it is 13. So, allocate 13. Now 1 plus 13 is 14. So second row is satisfied and first column was satisfied, and second column is out of 15 we have allocated 13. What is the balance now? 2. 15 minus 13 is 2. So now you have to move for the third row and second column. So x32 equals to minimum of. So total availability for the third row is 13 and total requirement for the second column is 2. Already we have allocated 13 here. Out of 15, 13 was allocated. The remaining balance is 2. So 13 comma 2. 13 comma 2. So answer is 2. x32 is 2. Right? It is 2. Now 13 plus 2 is 15. Okay. Now here out of 13 we have allocated only 2. So what remains here? 11. Remaining balance is 11. Right? So you have to move to the third row and third column. Okay. x33 equals to minimum of. What was the balance? 11. And here column total is also 11. So 11 comma 11 equals to 11. Okay. This is the final allocation. In the final allocation, here you need to get row total. I mean the total availability for the particular row and total requirement for the particular column must be equal. Okay. This is the final allocation as both the availabilities in the origin and requirements in the destination are satisfied simultaneously. Okay. Then you rewrite the given transportation problem once again along with these positive allocations. Okay. The obtained feasible solution is shown in the following table. D1, D2, D3, O1, O2, O3. This is BJ and AI. X11 is 9. We have got the answer as 9. Then X22 answer is 13. X21 answer is 1. Then X32 we have got the answer as 2. And X33 answer is 11. Okay. Now the transportation cost is determined by z equals to double summation Cij into Xij. So C is cost coefficient, and X is number of units or number of articles, right? 2 into 9. Okay. Then plus 1 into 1 plus 3 into 13 plus 5 into 2 plus 3 into 11. Wherever we have allocated the number of units, that should be multiplied by the cost coefficients. So 9 into 2 plus 1 into 1 plus 13 into 13 plus 2 into 5 plus 11 into 3. So total is 101 rupees. Transportation cost is 101 rupees. Now number of positive allocations equals to 5, that is 1, 2, 3, 4 and 5. Okay. And m plus n minus 1 equals to 5. Why it is 5? M is number of rows and n is number of columns. Number of rows 1, 2, 3 and n is number of columns 1, 2, 3. So 3 plus 3 is 6. This is 3 and this is 3. Minus 1. 3 plus 3, 6. 6 minus 1 is 5. Okay. So number of positive allocations is equals to m plus n minus 1. Okay. Thus the obtained solution is non-degenerate. Number of positive allocations equals to 5 and m plus n minus 1 equals to 5. Therefore, number of positive allocations equals to m plus n minus 1. Thus, the obtained solution is non-degenerate. This is the solution for the given transportation problem.